Yes, we did that.
Okay.
Good afternoon, class. Today we're going to look at logarithms. This is a long lecture, I'll tell you that much right now, but hopefully by the end of this class you'll be impressed with what all you can do that you weren't able to do at this moment right now. We're going to assume in this discussion, just like we did with exponentials the last time, we're going to assume that any time you see the letter B, we'll assume that it's a number that's positive and not equal to 1. As I was telling the class, I don't like using B's for exponents, but it can't be for variables except when discussing exponents and logarithms. Recall the last time we said for an exponential function, is written in the form y equals, or f of x equals, b to the x. And what's different about an exponential function is that the variable x is up there in the exponent. That's what's different. The variable is in the exponent. Now, a logarithmic function y is equal to log, one of the few times I use cursive, that says log to the base b of x. That b is a subscript, and yes, you're going to have to be typing subscripts. There's a hot button for exponents they call superscripts. There's a hot button for subscripts that will now start appearing in the toolbar as well. Y equals log to the base b of x means b to the power y is equal to x. A logarithm is just a fancy way of expressing an exponent. It's just a fancy way of expressing an exponent. And look at this right now. For an exponential function, it's y equals b to the x. Look at what a logarithmic statement says. Instead of b to the x, we have a b to the y. And instead of the y being by itself, on one side we have an x.
So it looks like you switched the x and y.
I switched the x and y. The y became an x, the x became a y. That means these things are inverses. Remember, that's the definition of inverse. You're swapping the x's and y's. Logarithmics and exponentials are inverses of each other. And that'll be important. But let's just make sure we understand what this definition is saying. Oh, by the way, that little subscript there, that is called the base. The thing that follows the log notation is called the argument. I remember back at a time when it used to be called the parameter. Seems like over the last 40 years it's changed so that the argument is the thing that follows the logarithm. Many times I just say the thing that follows the log notation. After the log base b, that thing there is the argument. And let's see if we can understand that definition. I have a logarithm I want you to evaluate. Help me evaluate. Log base 5 of 25. You're asking yourself, here's my blue box. Base to the power on the other side is equal to the argument. So base to the power on the other side is equal to that argument. 5 to what power gives you 25? That's what you're asking yourself. 5 to what power is equal to 25?
What exponent do you put on 5 to get 25?
No,
I was about
not
to say, don't say 5.
5. That'd be 5
Five?
times 5 times 5 times 5 times 5.
It's 2.
2. That's
Exactly.
it.
Y'all hear that?
Because 5 squared is 25. I have another one. This goes back to one of those that first property of exponents the last time. Log base 7 of 1. You're asking yourself, 7, here's what you're asking. 7 to what power is equal to 1? 7 to what power gives you a 1? It's one of those properties of exponents. The first one we saw the last time. 0. It's that definition of 0 exponent. And it really doesn't matter what that base is. As long as it's a positive number and not 1, the log of 1 will turn out to be 0. Now, just like with exponents, it used to be hard to type those powers. And logarithms were especially bad when it came to trying to type the things because of those subscripts. Old-fashioned typewriters, you couldn't be shrinking the font down and stuff. And so they came up with 2 special logarithms that don't require subscripts. I'll say 2 special logarithms.
Sometimes they pop up right off. Other times we're almost through with the assignment.
Without subscripts. Every other logarithm has to have a subscript. There's just 2 that don't require it. The first one is called the common log. I'll Roman numeral them. Common logarithm. Or just the common log. It's the logarithm to the base 10. So, if your subscript is x, and realize powers of 10 are, if you're trying to work with exponents without, why is it blinking?
No, I'm making the calculator bigger so I can see.
Oh, I thought that monitor over there was blinking.
I think it's just this.
Oh, okay. Let's see, what was I saying? Oh, back in the olden days, powers of 10 were easy to work with because 10 to powers were just adding on zeros, moving the decimal point to the right or to the left. So that was a very popular logarithm back in the day before calculators because it was easy to raise 10 to powers. So it was decided, since this was the logarithm that most of the old-timey algebra books used, they decided if they were referring to the common logarithm, log base 10, they just denote it logx. If your calculator has a plain log key, no subscript, just an log key, then that is a log base 10 key. The second special logarithm is called the natural log. The natural log, do you remember that irrational number, the natural exponential, that we denote with the letter E? That is the base of the natural logarithm. Wasn't it about 2.718?
281828 and then a 5 or something.
Instead of writing log base E of x. Now the natural log is by far the most common logarithm that's used in scientific and business calculations. And so it was important that they had a way of denoting this thing without the subscript for ease of typing. And the good notation, log, had already been used. If you see log and no subscript, that's a log base 10. So someone came up with the idea. They wanted the notation to start with an L, okay? L for logarithm. They decided just reverse those initials. The natural logarithm would be denoted ln and x. So if you see an ln, unfortunately it's always typed, and so it incorrectly to many people looked like an in when it's typed. And you're going to have to be typing in these LNs. It's not an I. It is a lowercase l. Do not use an I for that notation.
In fact, right now might be a good time to review or to reiterate something we said at the beginning. On Pearson MyLab, never type capital letters and never hit spaces either. Okay?
No space, no capital letters. The only thing that can be, if it's not a capital I, it's a letter, has to be a lowercase l. If you remember, logarithm starts with the letter L, then you shouldn't have a problem with it. I'll still get people with their little emails because, well, they typed the answer and it was counted wrong. No, you typed an I in and not an L in.
And really, what I think at that time is, wow, they really deserve to get the problem wrong.
I hate to say it.
They're
going to be
They
mean.
didn't know that this is supposed to be an L after listening to those lectures
and us
hearing
talking
us
about
talk about it. So it'll count it wrong if you type an I.
And okay. Now we said that exponential and logarithmic functions are inverses. Now remember we said that if you perform inverse functions consecutively, one after the other, you'll end up where you started. So, or they'll cancel each other out. I think we were saying that. And so, exponential, I am going somewhere with all of this, exponential and logarithmic functions to the base b are inverses. So if you perform the two functions consecutively in either order, they're going to cancel out. It doesn't matter if the log base b is written and then the exponential b to the x, log base b of b to the x, they're performed consecutively, they cancel out, leaving you just x. If we had the exponential base written first, b to the log base b of x. They're inverses, they cancel each other out, leaving you just whatever that argument is there. And with that in mind, let's get started with the homework. I'll give y'all a moment to catch up with me.
So
if you think of it this way, this one here, to see how that they're inverses, I think it's easy to see that if you look at this statement here. You're asking yourself, b to what power gives you b to the x? B to what power? The only thing that you could have here. B to what power gives you b to the x? The x power.
b to the x is b to the x.
For our purposes, when the exponential and logarithmic functions are performed consecutively in either order, they'll cancel each other out, leaving you the argument or power, whatever's left.
So this little small number would have to be the same, and so would the big number.
Let's get started with number 1. X equals log base 3 of 1 over 81. You're going to have to remember those properties of exponents. You're going to have to remember what we were doing the last time.
And also, these instructions say solve the equation. Y'all know what solutions to equations look like? It should be x equals a number, and that's your solution that you typed right here. Not the x equal, but here we have x equals all of that stuff. We just want x equals a number.
Okay. We know that if we could write this stuff here as a power of that base, then the two bases in the log notation will cancel out. And the answer will be whatever that power is. The subscript is a 3. I can write 81 as a power of 3. I know how to do that. That's log base 3 of 1 over 81 is the same thing as 3 to what power?
How many 3's do you have to multiply together to get
81? 4? Okay.
Mm-hmm.
We're trying to get this number written as a power of the base. So we need a 3 to a power. We sort of have a 3 to a power there, but there's that 1 over. We have to get rid of that 1 over. So we have log base 3. What can I do? I want to write this as 3 to a power. It was one of the first things we did in class on Monday. Wednesday, you're right. Let's see, where is it?
I remember how to get rid of a 1 over. It's right here.
Mm-hmm. Y'all remember negative exponents? We're going backwards here. 1 over 3 to the 4th. We drop the 1 over, and what do we have to do to the exponent? Make it negative. 3 to the negative 4. Do y'all remember doing that? That's why we were doing that stuff. All those properties of exponents will be essential here as we move through logarithms, because logarithms are just a fancy way of saying an exponent. And this is 1 over 81 is the same thing as 3 to the negative 4 power. Any questions on our logic there? Because once we've done that, we have the logarithmic base 3, exponential base 3. They're performed consecutively. They cancel each other out. And what are we left with as our answer? Negative 4. Correct.
So when it says solve that equation, you need x equals a number. And we have it. X equals negative 4. But in order to get that number, you're going to have to cancel out that logarithm.
And the only way to get rid of that logarithm is to get 3 to a power immediately after it.
And I remember as a student thinking when I saw this the first time, well, wait a minute. What if instead of 81 there were a 17? You agree you could not possibly write 17.
Then we'll see how to do that on 1 week from today, okay?
Mm-hmm.
But these, they have to be set up so that you can get a common base.
And actually, most of the time when you're using these in real life, you're going to have a common base.
You're going to have a common base, that's right. Type in the answer, negative 4. Any questions there? Number 2 looks horrible. X equals log base 6 of the 4th root. Where's my green? What color? I mean, there. We want the 4th root of 216.
Well, if we're going to cancel out that log base 6, what big number do we need after all of that?
What do we need right here?
Oh,
do I need
I don't see where you're pointing.
No,
okay.
Yeah. What number do I need written as a base here to cancel out that log base 6?
Just like right here, we had a little 3. What number did we need in order to cancel?
What number did we need after that little 3 to be able to cancel it? A big 3? So, to cancel out this 6 here, what number do we need here as a base of an exponent? 6? Okay. What I'm going to do, I said the last time, you need to get used to the idea when you see a radical, rewrite it as an exponent. So the first thing I'm doing is rewriting that 4th root. So we have log base 6. No. of 216 to the 1/4. Okay. Remember we said a fourth root is the same thing as a 1/4 exponent. We need that 216 to be 6 to a power. We need 216 to be 6 to a power. Can we write 216 as a power of 6? Tony, where's that calculator of yours? We know 6 squared is 36. That's not it. What about 6 times 6 times 6? What about 6 cubed? What's that going to give us? There it is. So we have log base 6 of 6 cubed Do you see where I'm going with this, Tony?
Yeah, I would have done it in one step.
Mm-hmm. We now have a power raised to a power. What do we do with the power raised to a power? We saw this the last time. I'd hate to keep saying that. I hate to keep saying we saw this the last time. A power raised to a power. Let's look back here. Where were we doing? Oh, here we had a power raised to a power. What did we do? Power raised to a power. It's called the power rule of exponents. What do you do when you have a power? Here we had an e to the 6th raised to the x. A power raised to a power u. Multiply 3 times 1/4 gives me 3/4. Three times 1/4 gave me 3/4. What can I do? I think we're through with the problem. What can I do? Cancel out. The logarithmic to the base 6 and the exponential to the base 6 gives a final answer just of 3/4. Tony would have looked, he would have gone straight here. Here's how he would have done it. He would have said that fourth root. Do y'all remember that? Let me find it. Where is it? It's all back here. Where is... Oh, here it is. Remember what they mean? We had said, first of all, an exponent of 1 over n is an nth root. But suppose the exponent is something other than a 1. That radical, that index on the radical, that's the denominator. So the index on the radical, the 4, is the denominator of the fraction in the exponent. The numerator is the power that's on that base. Well, we needed a 6 cube, so 3/4.
Power root. 6 cubed, 4th root. And I need to type in that answer. 3.
If you see a radical appearing with logarithms, you must rewrite it using an exponent. It'll be a fractional exponent. Any questions there? That's one of the problems that requires more thought. Go back to it. There. Any questions?
And again, it's got to have that common base. Okay?
Or else we're not ready for it. We'll see that in a week. Suppose instead of a 216, that had just been a 7. Log base 6, 7, 7's a prime number. You wouldn't be able to change it. Number 3 looks hard. Oops. X equals 2 to the log base 2 of 8.
And it says solve the equation. We want
X equals
a number. We don't want all that logarithm stuff Well, is this hard or not so hard?
Look at what I have at the top of the page. Is there something there that'll help us answer this question? I know the answer just looking at it. I know. We said if the base of the exponent and the base of the logarithm are the same and they're performed consecutively, one after the other, what happens? They cancel each other out. And what are we left with in this case? Just that number 8.
X equals 8. And the natural question is, what if there wasn't both 2's here? What if it was a 2 and a 3?
It's not going to happen because you're going to be the one choosing what number to write right there. If you knew, I want to cancel out that log base 2, what number do I need to put here to cancel it out? You're the one choosing. Well, you put whatever that exponent is there, as you're about to see in problem number 4. Well, did you type in the answer?
No. Number 8. And next. Notice on problems 1, 2, and 3, they're all in the form x equals. The x is already isolated. So all we have to do is cancel that logarithm, so we just have x on one side, a number on the other. Well,
what about number 4 though?
Is the x already isolated? Is x by
itself?
itself?
No, the x is not isolated.
We've got to get that x. What our goal is to get x equals number. Written it down here?
Mm-hmm. Yes. Okay. What I'm going to do, I want to cancel out that log base 3 from this equation.
You have a small 3.
I have that small 3 there. What I'm going to do, if these two quantities are equal, then 3 to those powers should be equal. I'm putting the base there myself. The original problem has now become exponents. It looks weird, but this is saying 3 to the log base 3 of x is equal to 3 squared. It's like those old-fashioned typewriters where the exponents were the same size as everything else. 3 squared, I know that. That's 9. What can I do here with the 3 to the log base 3? What's going to happen? They perform consecutively, exponential base 3, logarithmic base 3. They cancel out, and what are you left with? Just that x, for x equals 9.
You know what?
We're able to turn the original problem into exponents using the base of the logarithm.
Let's do one more, though.
Mm-hmm. Okay, I'm going to make up...
I've already said similar problem.
Okay.
This is another problem 4. Just
log
to make sure.
Base 5, log base 5 of x is equal to 2.
Is the x by itself?
No.
No. Okay.
To solve this logarithmic equation, we have to use exponents. The stuff here, all of that's about to become powers. What will we use as the common base on both sides to cancel out that log 5? Okay, that 5 there becomes a base.
I said you're choosing what number to put there.
That's right. You're choosing the number to put there.
You wouldn't put a 4 because it could have canceled.
That you put that 5 to the log base 5, that's canceled, leaving us just an x equals. Now what's on the right side? It looks funny, but that's because it's written so big, but it's saying 5 squared, which is 25. You have a new technique you can add to your bag of tricks for solving equations. If it's a logarithmic equation, you can cancel out the logarithm by turning everything into exponents and use
Go ahead.
And use the base of the logarithm as the base of the exponent.
Mm-hmm. Oh wow, that's a nice. Let me start those properties.
Okay.
Now we're going to get 3 rules of logarithms. Tim, you talk. You have the microphone.
Okay, I'll say properties of logarithms. Properties of logarithms. We have 3 properties here that have names to them. The first one is the product rule. The product rule of logarithms says if you have log base b of a product, m like money times n like Nancy. The log of a product, notice inside the argument, m and n are being multiplied. You can rewrite that as log base b of m plus log base b of n. If the arguments are being multiplied, you can add the individual logarithms. Remember I said a logarithm is just a fancy way of expressing what? An exponent. There's a product rule of exponents. I don't know if we used this one the last time or not, but here's the product rule of exponents. It says b to the m times b to the n. If you have the basis being multiplied and you want to write it as a single power b, what do you do to the exponents? You add them, m plus n.
Like x times x is x squared.
1 plus 1. If you had x squared times x cubed, that's 2x's, x times x, times 3x's. How many x's do you have total? X squared is 2x's, x times x cubed is 3x's, x times x times x. How many total x's do you have there?
Not 6.
5. So you added the exponents. So if the bases are being multiplied, you add the powers. If the arguments are being multiplied, you add the logarithms. There's a strange similarity there. Here you're adding the exponents. Here you're adding the logarithms.
And if they know the product rule, most students can guess the quotient rule. To multiply, you add.
What do you think you're going to do when we're dividing the arguments? Log base b of m divided by n.
So you're writing division as a fraction. Y'all want to guess?
Subtract.
Exactly.
Log base b of m minus log base b of n. And there's a quotient rule for exponents. There's a quotient rule for exponents. It's most people think of it as the cancellation property. You have b to the m divided by b to the n. You want to write that as a single power of b? Well, you cancel out the n b's, and how many do you have left? M minus n. If you had something like x to the 5th divided by x squared.
Cancel 2.
Cancel 2 x's above and below. How many x's do you have left over? 3. 5 minus 2. I agree with 3. So there's a quotient rule for logarithm, and it's strangely similar to the quotient rule of exponents. Here we have the exponentials to the base b being divided, so you subtract the exponents. Here the arguments being divided, so you subtract the logarithms. And we'll see examples using these properties in a moment. Here I just want to state the 3 properties. The third property, probably people think of this as the most bizarre property. It's the power rule of logarithms. Log base b of m raised to the n power. Wait a minute. The exponent is on the argument. It's on the entire argument. Just a moment ago, I used the power rule of exponents. Do you remember that? I tried to remind you all of the power rule of exponents a moment ago. If you have a power raised to a power, what do? You multiply. 3 times 1/4 became 3/4. Power raised to power, you multiply. Remember, we were doing that quite a bit at the end of class the last time. Let's see. Oh, here I'd even stated the power rule. Power raised to power, you multiply. Power raised to power, 2 times x, gave us a 2x as the exponent. So, where are we? A power raised to a power, you multiply m times n. Okay. I said a logarithm is a fancy way of expressing what? So we have an exponent raised to a power. We have a power, that log base b of m is a power raised to a power, so you multiply. You take that front power, move it down, and write it as a factor. A power raised to a power, you multiply. This power rule allows us to pick up the exponents on the argument and move them down and write it as a coefficient. We're going to be taking single logarithms and expanding them, writing them as multiple logarithms. Then, like we always do in math, we'll go backwards. They're going to give us a series of multiple logarithms, and we'll have to go back and condense it to a single logarithm. And we'll be using these 3 properties to do so.
Now, we're not ready to do this problem, but I just want you to see what we're trying to say. We're going to rewrite this big logarithm.
One messy logarithm.
In a moment, it'll be easy.
Well,
in 15 minutes.
I was going to say.
In 15 minutes, it'll be easy. Okay?
Okay. First of all, condense logarithms.
That's when you take 2 or more. No, you're not condensing. You're
expanding. We're going to expand first.
Take one logarithm and write a lot of different ones.
I know why I'm thinking of condensed. I'm thinking of condensed soup. That's why.
Wow. Well, I'm not going to ask why you're up here thinking of condensed soup.
Because I've been cooking these recipes with all this condensed soup. I don't know what happened, but I got into a cooking phase. It's over. Okay? But still, with all this different condensed soup, that's why condensed is running through my mind. But expand logarithms means to write one logarithm.
Usually a really messy one, like the one I showed you on number 5.
As multiple logarithms. And the procedure will follow. Usually you look at the argument and ask yourself, is there a fraction? Usually there is. So in that event, you'll apply the quotient rule.
So rewrite it as using subtraction.
Then the second, you'll apply the product rule. If there's any products, write it as a sum.
And once you don't write number 3. Let them figure it out when we get to that point.
Okay, I like that. Okay, I'm going to leave number 3 empty, okay? It has nothing to do with logarithm properties. It's just an algebraic process we're going to have to do in a moment. I bet y'all can figure it out. Step number 4, the last thing we'll do is use the power rule. I don't know why I'm saying apply. Why don't I just write use? That's fewer letters. So we'll use the quotient rule first if our argument has any fractions in it. Then we'll use the product rule. There's this third step that I'm not going to write yet. Okay, I'm going to see if y'all can figure it out. And then the last thing we'll do is we'll get rid of exponents using the power rule. And I have an example right here. Yes, I have an example right here that I want them to do. I want to expand.
Now the instructions, again, it's so many different people writing these. Some people will say expand, which is the formal word. Others will say write it as a sum or difference.
Okay.
Got red ink to be underlining.
I guess so. Yeah.
All right. We're going to try to notice how this is big argument here. We're going to try to rewrite this with a lot of exponents and real small arguments. The argument's the thing after the logarithm. So
I'm going to go through and I'm going to follow this 4-step procedure. Then we're going to look, once we get to the final answer, we're going to look at it and we're going to figure out a way to get these things expanded quickly in only 1 or 2 steps. This first problem, I'm going to go through the entire process, but you need to be looking at patterns and noticing a pattern. And that's the thing, that's how we're going to start expanding. It'll get to where, for these expansion problems, we'll do it in 1 or 2 steps, at usually
15
1
minutes,
step.
they'll be able to look at this and just type the answer in.
That's correct. In 15 minutes time, you'd be able to look at this and type in the expansion. Here we go. The first thing we're going to do, we're going to apply the quotient rule. The quotient rule says that the log of a fraction is equal to the log of the numerator minus the log of the denominator. So I'm going to write that as log base 7 of the numerator x squared y to the 1/3 minus, that fraction bar becomes that minus there, the log of the denominator, w to the 4th times a.
Subscript.
Oh, I forgot my subscript. 7. Log base 7. We applied the quotient rule. The log of a fraction is the log of the numerator minus the log of the denominator. Now we want to apply the product rule. Do we have any products here? Do you have anything being multiplied together?
Put 3 dots everywhere you see a product.
Log base 7 of x squared times y to the 1/3. So we have a product right there. Where else do we have a product? Times a. Okay, wherever you have those red dots, you can split it up as a sum.
So you're using the product rule twice.
Okay, the log of a product can be written as the log of the first factor plus the log of the second factor. So we have log base 7 of x squared plus log base 7 of y to the 1/4. 1/3. All of that stuff, these first 2 terms, came from that first logarithm there. Notice how I enclosed these 2 logarithms in parentheses. Then we have a minus. This red minus is that red minus there. We're going to have to do the same thing with this second logarithm. I'll have to write small. Yeah, you're right. I'll have to write small. That's log base 7 of w to the 4th plus log base 7 of a. X squared and y to the 1/3 were multiplied, so we were able to add the individual logarithms. W to the 4th and a were multiplied, so we're able to add those individual logarithms. We just now applied the product rule. There's some step right here, that third step, that we didn't write. And I said it didn't have anything to do with properties of logarithms. It's an algebraic property. What are we going to have to do? I'll get us started. This first thing here, that first set of parentheses, is there anything in front of it to distribute? No, those are unnecessary parentheses. I just have them there to show that both of those logarithms came from that first logarithm. So I'm going to drop those parentheses here. I'll just write it as log base 7 of x squared plus log base 7 of y to the 1/4. 1/3. What is it?
You wrote 1/4.
Oh, I did.
You made up this problem.
I know, so I should just change it to 4 then. I made it up. I'm going to change the 3 to 4. No. That's a 3. That's a 1/3 there.
Okay, we've stalled long enough. What's the third step?
What are we going to have to do? What did I not write here?
My cursor.
Okay, we're going to have to distribute the minus sign. Every logarithm that came about from the denominator, you have to distribute that minus sign, and so you're going to have a minus and a minus. Distributing the, and let me see, I'm going to write here, distribute minus. So that's a log base 7 of w to the 4th and a log base 7 of a. Any questions up to this point? Keep in mind, our goal will be to go from this problem here directly to the final answer. We're now ready to get the final answer. Use the power rule. Okay, remember the power rule says if you have an exponent that's applied to the entire argument, you can bring it down as a coefficient. An exponent applied to the entire argument can be brought down as a coefficient. Bring the 2 down. 2 log base 7 of x plus, will I have a coefficient on the second one? If so, what is it?
I can't read it.
They can read it there.
Yeah, I know. The 1/3?
That'll become my next coefficient. 1/3 log base 7 of y.
So we're moving the exponent in front of the letter L.
Minus, what's this third term going to become? I couldn't hear you.
4 log base 7.
Okay, that's right. You move the 4 down, log base 7 of w minus, hey, do we have an exponent to move down on that last one? It's just a log base 7 of a. Your goal is to go from this problem directly to the final expansion. Here's the final answer. I'm not going to be showing that any more of this middle stuff. No more. When I have to expand, if there's a radical in the argument, I'll write that radical using an exponent.
Like this 1/3 exponent is
That's a cube root. If it had been a cube root, I would have I would have written it as an exponent. So in the problem, like that problem we were looking at, Tony
Number
showed you a
5.
moment ago, number 5, there's a radical. We're going to have to write that as an
Yeah, we
exponent.
have a square
But then the
root
rest of the stuff, you're going to go from the single logarithm to the expansion.
I like to begin by putting in red fraction bars and multiplication. Put the 2 red dots on there. Ignoring all of that. Oops, y'all don't see what I just have up. And we're trying to ignore this. How do we go from here to there?
Let me ask you something. How many unique factors do we have on top of that fraction?
How many things are being multiplied together? 1,
2, okay. How about on the bottom, how many are being multiplied? 2. 2 plus 2, you're going to need 4 logarithms in your expansion. Now, each individual factor became an argument. You had a factor of x, that became an argument. You had a factor of y, that became an argument. You had a factor of w, that became an argument. And an a became the argument. What determined the signs? The first 2 logarithms, notice there's no sign in front of that 2, so you assume that's positive. There's a plus. I guess the better question is, why did the last 2 logarithms, why were they preceded by minuses? When you look at this, 2 of them had positives, 2 of them had minuses. Which ones are preceded by minus? There's a big difference about the placement of x, y, and WA. What's the difference?
I think they don't know understand the question.
Okay. Why do I have a minus here in front of these 2?
I'm just going to tell them.
It's a denominator?
Yes,
it's in the denominator. The
exactly.
factors that are in the denominator. If it's in the denominator, as soon as you use that quotient rule, you're going to get stuck with that minus in front. And then you use the power rule, and you got to distribute. So any factor from the denominator has to have a minus in front of the logarithm. Factors that are not in the denominator have positives in front of them. It has minuses in front of them. I said the wrong word a moment ago.
Okay. Exponent goes in front of the letter L. The stuff is positive if it's on top. It's negative if it's on bottom. Why don't you just do one without all of those steps?
I have one I want to do.
I hope it has a 1/4 in it.
It doesn't, but I'm gonna make it a 1/4.
Okay. Since you wanted a 1/4.
Y'all are so quiet. Oh goodness. And I can't even think to myself, Tony did something to log base 5 of, here goes, a cube c to the 1/2 all over 4x square y to the 2/3. Can y'all read that? First thing, I see that I have a fraction in the argument. That means I'm going to have some minuses appearing. You can split them up at multiplication and division. Well, there's a product up here. How many unique factors do we have on top? You have an A times C. That's 2 unique factors. How many unique factors do we have on bottom? Be careful. Don't answer yet. Let me read this out. It says 4 times x squared times y cubed.
Y to the 2.
There are y to the 2/3. There are 3 factors on bottom, 2 on top.
How many minus signs are we going to have in our answer?
3, because we have 3 factors on the bottom. How many total logarithms do we need in the expansion?
1.
1. We have 2 factors on top, 3 on the bottom. How many total logs is that going to be? 5. So we have log base 5. 1, 2, 3, 4, and 5. Okay. It's going to the expansion's going to spread out over 2 lines, unfortunately. The first logarithm, the argument is a. Where do I put that exponent 3? In the front. We're moving on to the next logarithm. C is on top. So what sign are we going to have? Plus or minus? I couldn't hear you.
Plus.
Plus.
Stuff on top has pluses in front of it.
The stuff on bottom will have minuses. The argument is a C. Where am I going to put that 1/2? In front of that second logarithm. We've done everything on top. Now we're moving down to the bottom. That 4 is on the bottom. So what sign will we have? A minus. The argument is 4. Do we have an exponent on that 4? No. No. It's a 1.
Yeah,
and, so,
right.
and I think if you type the 1, unfortunately, I think if this were my lab, I think if you type the coefficient of 1, they'd count it wrong. So, okay. We're still down here in the bottom, so we still have another minus. The argument is x. What am I going to do with that 2? Yeah, that's what, the reason I'm saying is because I don't have much room there. I'm going to have to squeeze it in there. We have one more factor on the bottom. It's that y. What sign are we going to have in front of this logarithm? Plus or minus? Minus. Once you move to the bottom and start having minuses, you have to have minuses the rest of the way. And where am I going to put that 2/3? Okay, it's in front of the logarithm.
Y'all see how he did that? This is one of those times showing a lot of steps does not make it easier.
As a matter of fact, it just gives you more chances to mess up. It's better for these expansions for you to notice the patterns. Factors that are on top will have positives in front of them. The factors on bottom will all be preceded by minuses.
And first of all, you separate at multiplication and division.
You can
separate. Years ago, a student telling me, I don't get it. You seem to think those little red dots are important. And I was like, yes, they're important. That's where you separate them. You separate logarithms at multiplication and division.
You cannot separate them, addition and subtraction. Notice our argument, I don't see a plus sign or a minus sign. If you have a plus or a minus in your argument of the original problem, you're going to be stuck with that same plus or minus in the argument of your final answer. And you'll see what we mean by that as we move on, but we better go on to number 5 right now. Oh, I hope you haven't been timed out. Log base 7. Oh, the square root of x times the... Oh, look at that. That 3 is directly above that hook. Do y'all see that? Move the little hook right there. That 3 is saying a cube root of y all over.
To the 7.
Notice something. That 7, this 3 is immediately over that hook, so that's a cube root. It's not saying a square root of x cubed. That 3 is saying the cube root of y. Is this 7 directly above that little hook there? So the 7 is the power on the x.
W.
The w. W to the 7th. This last thing is the square root of z. It's a square root of x times a cube root of y all over w to the 7th, and that's the square root of z. We're not going to do it just in one step. We're going to break this into 2 steps. I said the last time to add this to your bag of tricks. If you're working with logarithms or exponentials and you see radicals, rewrite them using an exponent. So we're going to rewrite this problem so there are no radicals. The square root of x. What exponent is the same thing as the square root of x? It's the square root. No, not negative. Wait a minute. Let me find it. Here it is. A square root is the same thing as the exponent. 1/2. And in general, an nth root is the same thing as the exponent of 1 over n. So that square root of x, that's the same thing as x to the 1/2. Uh-oh. We have a cube root of y. How am I going to write that as an exponent? That's y to the 1 over 3, 1/3. And a cube root is the same thing as an exponent of 1/3. W to the 7th, that'll just stay a w to the 7th. The square root of z, how am I going to write that? Z to the, okay, another half. A square root is the exponent of 1/2. How many logarithms will I have in this expansion? How many distinct factors do I have? Okay, on top, how many factors do I have? 2, x times y. Now we're moving down. How many factors do I have on the bottom? 2. So 2 plus 2. How many total logarithms will I have in my expansion? 4. Okay, here we go.
How many minus signs are you going to have? 2.
You'll have a minus in front of the log with the w and a minus in front of the log with the z. So we'll get started on top. We have a log base 7 of x. Where am I going to put that 1/2? In front. I agree. Now we're going to deal with that y. Will I have a plus or a minus? Plus, because the y is still up on top. So we have a log base 7 of y. What will I do with that 1/3 exponent? It goes in front of the logarithm. Now we're moving to the denominator. So plus or minus? Minus. Okay. We have a log base 7 of w. What am I going to do with that exponent there? It goes in front.
Now, before you write anything else, can y'all call out? Have you got the pattern? Call out what we're going to write right here. Just in the order. What sign do I put?
What's that last term going to be? First of all, plus or minus? Minus.
Now, what's the very next thing he's going to write? 1/2.
1/2. Log. Okay.
Y'all hear that? Good.
Log base 7 of z.
I remember the time the student, great student, she said, golly, it takes a lot longer to type this stuff in than to actually get the answer. Yeah.
Yeah.
But fortunately, on this first one, it's multiple choice. So let's see. Which one is it?
Oh, wow.
Oh.
We've been going an hour and 4 minutes, and all we've done is 5 problems.
So we only have 20 to do. So.
Yeah. This
is it C?
A, B, C, or D? Which one?
It's sure not D.
It has to be C. That's the only one that has a minus 1/2 log base 7 of W. So.
Check. Could you do log base 7 of x squared plus y squared? You see, in
Okay.
these multiple choice ones, the way it says cannot be simplified, let's show you one that can't be simplified. Remember, logarithms are separated at
multiplication and division.
You've got to be able to draw the red dots and the fraction bar. Can I do that here on this one? Is there any multiplication place?
Multiplication or division here in this argument? No, that cannot be expanded. If you're
Or simplified,
whatever you want to call it. I'll write it like this. Log base b of m plus or minus n cannot be expanded or simplified, whatever you want to say.
Separate logarithms at multiplication
And division.
not at
Addition
addition
or subtraction.
So let's see if we can get some of these problems done quickly now.
Go back.
Oh, go back.
Right.
Oh.
They weren't ready to, they
Oh.
weren't through
Writing
writing
down.
what I'd written.
Here.
Log base b of sum or difference cannot be expanded. If your argument has a plus or a minus in it in the original problem, you're going to have that same plus or minus in the argument of your final answer. Okay, now let's go on. What's the next one?
And I've started putting little notes on here. Never type capital letters or hit the space key. If you're typing it incorrectly, each log will automatically bold.
Maybe you should remove that in, because it sounds like if you're typing it incorrectly, you mean wrong. If you're typing it wrong, each log will automatically. If you're typing it correctly.
Well, you know I can't just change
I
it
know
like
it.
that, okay? And
Logarithms always begin with a lowercase letter L, not a capital I.
you're going to see this little thing over and over. When you click a problem the first time, it shows you that. And after the first time, if you want to read it again, it's right here. I claim this problem you can do without a lick of work, just type it in. But Tim's going to write it down so you can see the red dots and the red fraction bars. That's where you separate them.
I don't know if it's Z to the, is that a Z to the 6?
Z to the 6.
Okay.
Oh, this is going to be great. We have a B and a 6.
Yeah, we have a base B and we have an exponent of 6. Okay.
How many minus signs are we going to have in our answer? We're going to have any minus signs?
We're going to have minus signs because I see what in my argument?
Fraction.
A fraction bar. How many distinct factors do we have on top? 2 x cubed times y. Then divided by,
So y'all
how
just-
many distinct factors do we have on bottom? 1. So 2 plus 1, that means we need 3 logarithms.
Why don't they just start calling?
Call it out. There's log base b.
Okay.
Do I have a number in front of this? If so, what is it? 2? I think it's a 3.
Unless
Did I
we
miscopy?
miscopied.
Wait, yeah, sorry. I'll clear my problem.
Oh, okay. It's a 3.
Oh, it's-
Okay, 3. The argument is x plus or minus. Plus or minus, plus,
Uh-huh.
and then log base b.
There's no exponent, so nothing goes in front of the letter L.
So there's no exponent, so no coefficient in front of the second logarithm. Plus or minus, minus. Are we going to have a coefficient? 6, that exponent. Correct.
If it looks to you like we're just writing the problem down and writing the answer,
You're
we
right.
are. If you want to see it done with a lot of steps, look at view an example. It's not easier, just longer. I remember years ago I used to show all of these steps, and it was my brother that told me, don't show the steps. It's easier. And I was like, no, the students want to see steps. He said, just try it. Go in there and try to do it without the steps. Oh, wow, that changed everything.
The only reason you want to do this is if you're working with, say, some bigger logarithmic function and you're trying to differentiate it or something in a calculus environment. You don't want to spend half a page trying to just get the thing expanded. You have to expand it quickly to get on with the rest of the problem.
So let me start typing it in.
Okay, this is the first time we will have typed a subscript. 3.
Now look at this. When I type L-O-G,
look at this.
Right now it looks like a 31-O.
L-O. There, look. If you type it correctly, that log notation will bold, and then you hit your subscript button.
Sometimes students will text me, and even email, and even show the work to prove. Or a screenshot.
They typed L-O-G and it didn't bold. No, you typed capital I-O-G. And we say it over and over. And unfortunately, on tests, I'm almost heartless when it comes. I cannot believe they typed I-O-G instead of L-O-G.
Look at this. O.
Look at this.
Oops. Did it bold?
No.
What's wrong?
It's an I.
Not an L.
Logarithm starts with the letter L. Every log notation starts with the letter L.
If you use capital letters,
L.
Will it bold?
No. No capital letters in my lab. No space bars.
Okay, it bolded. I put the Y.
Wait a minute. You didn't put the subscript.
Oh, yeah, I didn't. Shoot. I always forget those subscripts. L-O-G subscript.
Y'all see where the hot button is down there?
That little subscript right there. And then what is it? A
minus
6
log base B Z.
Log.
So why's the Wi-Fi down? I do my phone all the time.
Your Wi-Fi is down? Well, it's working up here. At least the teacher Wi-Fi is working, okay? Because I connected, just to be safe, I'm connected not just through the Ethernet, but through the, if you have time after class, let's see if we can figure out what's happened. Have you changed your password recently? Did they make you change your password? No? Is anyone else using the student Wi-Fi?
But if I change password, you mean like for a student email or something?
Yes.
It did for me, but I don't know.
Oh, okay. Go on, number 7.
Okay, there's that same old thing, and Tim's right. It's not an easy task. I'll need to go in for next year and change it. So if you are typing it correctly.
It means I've typed in the answer. Do y'all do that, or is that just an East Texas thing? Do we say, I got to type in my answer? I don't just say type my answer. Is that just something from East Texas, or what?
I type in my answers. You put it in the box.
This is number 7. Oh, I love this. Look at that LOG notation. Do you see a subscript there? Say no. No, so that means you don't have we're not going to have
to type.
That's the common logarithm. The LOG without a subscript. So that'll be easier to type.
It's log base 10, but you don't type log base 10. I think I tried that last year.
And they'll count it
and
wrong.
it counted it wrong.
If they don't show a subscript in the original problem, you don't type the subscript in the final answer.
Hey,
Okay.
look at that cube root symbol. Are both of those letters under that cube root? The cube root is what fractional exponent? Do I remember? 1/3? 1/3?
Okay, so I'm going to rewrite that. You want the cube root of x, so that's x to the 1/3 all over. You want the cube root of z, so that's a z to the 1/3. And once you do that, this thing falls out very quickly. How many distinct logarithms are we going to have? How many distinct factors do we have on top?
Just one.
1, okay. How many on bottom? 1.
How
So
many minus signs are we going to have in our answer?
One.
just 1. So we'll start off, call it out as if you were typing it in. What's the first thing you type in? 1/3, and then log x minus, I agree. I couldn't hear you. Okay, 1/3 and a log z. Good.
I think Chloe's got the hang of it. Right? Hey, we haven't mentioned this, but if you go forward, could you go backwards? Chloe, could you go backwards if you had this?
Because we're going to be
6 and
doing
then
that
go
in a
back?
moment.
Yeah.
We're going to be going backwards in a moment. And we'll be following the same logic that we use to expand them when we start condensing.
Look, let's view an example. They're just going to go through it all.
Oh, keep going, Tony. Let's go on to number 8. We're
Wait,
getting.
okay, we're getting fast.
Oh, yeah. Okay,
Log-
1/3.
1/3. 1/3.
Get log. And notice it bolded x minus 1/3 log.
Make sure you get out of that denominator. Don't type log right here in the bottom of the fraction. No. Log, is that a y?
Z.
A z. Okay. Okay. Oh, there's
Number
that same old
8.
tip. Okay. Here we have one thing we got to do before we just type in the answer.
Log base g.
Yeah, that's a g, not a 9.
It's a fraction. And that is a square root of s. Notice that t to the 4th is not underneath that radical. The only thing that's under that radical is s. And on the bottom we have, is that an r to the 4th power?
Mm-hmm. One thing we got to do before we start expanding it, just one thing, and that's what?
If you see a radical within a logarithm, you must first rewrite it using an exponent. Okay, so we're going to write log base g. That's a square root of s, which means we would have an exponent of 1/2. Okay. A square root is the same thing as an exponent of 1/2. We still have that t to the 4th on top and an r to the 4th on bottom. How many distinct factors do we have on top? 2 on bottom. 1. So that means we have a total of 3 logarithms in our expansion.
Put your red dot, and
Okay.
y'all start calling it out.
We split up here at division and multiplication. So here we go. Call it out as if you were typing it in. What would you type in first? The 1/2. The exponent becomes a coefficient, and then you'd have log base g, and the argument is s. Okay. Next one, plus 4. I agree. Good. Okay, we're moving to the denominator now. We're moving down to the denominator. So we have a minus, and then the 4 becomes the coefficient. Okay. Great.
Chloe, have you
Good.
worked with logarithms before? No? Okay.
You can impress yourself at the end of class. If you follow what we're doing, you can impress yourself. Wow, I couldn't do this 2 hours ago.
And then you can go to your friends that have teachers
Log
that are
base
showing all those
g of
steps.
s plus
Subscript g. Look, if I do g and s down there, it's going to count it wrong. Only the g is in the subscript. S plus 4 log
base g of t
t, and then
minus
minus
4
4
log base g of r.
log.
After you type a few of those subscripts, you'll gain a deep appreciation for log and ln.
In fact, when we do accomplish our goal and be rulers of the world, I'm going to make one of my rules when working with logarithm properties. If there's no reason why it couldn't just be a log
Or an ln.
just use log or ln so you don't have to type in the subscripts.
Actually, you know what I'd do? I'd let them appeal to me, and I would look at it a case-by-case basis to decide whether it's an acceptable base or not. What do you think?
Good. Okay. This one's longer. I'm trying to figure out. Oh, does this one have an ln in it?
I think so.
I'm telling you that let me see.
Let's just look at number 9.
ln.
Oh.
Not capital I-N. Lowercase ln.
Oh,
It's a
wow.
logarithm, and logarithms always start with the letter L.
Okay, looking there, let me see. That is not saying a 6th root. Notice that 6, it's not right there over the little hook. That's just an x to the 6th. This radical is a square root, so it's x to the 6th and a square root of x squared plus 2 all over an x plus, is that a 2 to the 8th power?
This one's unusual because this
Alien.
is the first one we've done,
X to the
expanding, where there's pluses in the argument. Normally it's just multiplication and division.
You cannot split up a sum or difference. We have an x squared plus 2 in this argument. That means you're going to be stuck with an x squared plus 2 in your final answer. You have an x plus 2 down here. You'll be stuck with an x plus 2 in your final answer. You can only separate at multiplication and division. So with that in mind, the fact that I started this problem down here with hardly any room left should be a good sign. That means it's not going to be that long, or I would have gone to the next page. Okay, let's see. Where are we going to separate? It's x to the 6th times that square root, and down here we have an x plus 2. I guess I better rewrite that. We can't separate that. That x plus 2 has to stay by itself.
You have to do one thing first before you start expanding and separating.
What am I about to do here?
Rewrite that green square root as a green what?
Exponent
Okay.
of
What's the exponent going to be?
positive
1/2.
1/2. Okay.
Good.
And we still have that x plus 2 to the 8th on the bottom. Generally, for expanding, I do it either in 1 step or 2 steps. If there's no radical, I go directly to the final answer. If there's radicals, I rewrite it using an exponent, and then I write the final answer.
You could even say you rewrite it using a
Fractional exponent. That's
Now let's
right.
put the red dots in the red fraction bar.
I'd put it there and there.
So it's going to separate into 3 logarithms.
X is a unique factor, x squared plus 2 is a unique factor, and x plus 2. You cannot separate the pluses and the minuses. Or if there's not a minus, but if there were, x squared plus 2 has to stay together, x plus 2 has to stay together. So we're going to have 3 logarithms. We start, bring down the 6, ln, and then the argument is x. Well, we have a plus or minus next. Plus, because we're still on top. We have an exponent of 1/2. And then we have an ln x squared plus 2. Notice something. If your argument has addition or subtraction inside it, you must enclose it in parentheses. If you type in 1/2 ln x squared plus 2 and don't have those parentheses, they're going to count it wrong. The computer assumes that the thing that immediately follows the log is the argument until you get to a plus
Or minus.
And so if you want x squared plus 2 to be an argument, you've got to enclose it in parentheses. What's the next thing I'm going to type here? Minus.
8.
Okay, so we have the 8. And then the ln, you must enclose the x plus 2 in parentheses. If your argument has addition or subtraction, that addition and subtraction must be enclosed in parentheses.
X plus 1/2 right arrow ln parentheses x squared right arrow plus 2 close parentheses
Then minus.
8. Look at this. What did I just do?
His ln didn't bold.
You have no idea. I should start a file of all the emails I get. How do I make it bold? My answer's right, but I can't bold it.
Well, it's not right, because
it's
you
not.
think logarithms start with the letter I, not the letter L. Okay. Any questions there? If your argument has a plus or a minus, you're going to be stuck with that same. Switch back here real fast before we start. We're about to start condensing.
Yeah, we're gonna go
Your
back.
argument had a plus and a plus. You had to have an argument with the x squared plus 2. You had to have an argument with the x plus 2. You cannot separate at addition or subtraction. Number 10.
Someone said,
Number
no,
10.
wait, instead do this.
Wait, I better mention what it means to condense logarithms. If you see the instructions, condense logarithms,
That means write as a single log.
that means, if you're condensing logarithms, that means you're going to take multiple logarithms. I'll say write multiple logarithms. I guess I could have said write several logarithms as a single logarithm.
And instead of doing number 10 first, do this one. Here's an example. Condense 2 log x minus 3 log y. By condensing, so this is just the one that doesn't have a base, the common log. That means write it as just one logarithm. So go ahead and write equals.
If I'm condensing logarithms, I'll write my log notation, and then what I normally ask myself is, do I need a fraction bar? What do y'all think? Do I need a fraction bar?
Going backwards. How do we
Yes, because of what?
Because minus.
That
minus.
minus right there says we're going to need a fraction bar. Where's the x going to go?
Top or bottom?
Top. What are we going to do with that 2? Okay, it becomes an exponent. Where's the y going to go? On the bottom. And the 3? Exponent. I agree.
Now we're ready to do 10.
Now we're ready to do 10. Number 10.
Log base 3 of 11 minus log base 3 of 7. Someone that didn't know any better would say, well, it's surely
Log
a 4
base
comes
3
in.
of 4.
Yes,
A
4's
4
gonna
does not
No,
come
it does
in.
not.
I write my log base 3 We're condensing. We want to take those two logarithms, write them as a single logarithm. Do I need a fraction bar? Yes, because of that minus there says I'm going to need a fraction bar. What have I got on top?
Well, before you answer that, do we have any exponents here? Anything in front of the letter L? Say no exponents.
So no coefficients, so we won't have any exponents in our final answer. What will we have on top? 11. That's an assumed positive. That means 11 goes on top.
And on the bottom,
7.
Don't let the fact that they're numbers, they're trick you. Sometimes students can do this one, but when they see it with just numbers, they start subtracting the 11 and the 7. Oh, no. So let me write that in. Or type
Log.
that in.
Oh, you're going to type in the answer?
I'm going to type it in. Into the
blue box.
Yes.
Yeah, I
Log
understand.
Base 3. Right arrow. 11 over 7.
Okay. Okay, we've done half the problems. We have 20 problems here in this assignment, and they're all new material, so...
Hey, hold on. Well, go ahead and write it down.
Hey.
This is one. There's no radicals or anything. You could just go straight to writing out the answer. Or typing in the answer. C plus. Write it all down.
Okay.
So equals.
Now here's something. Notice they've typed log base 10.
Oh.
They're showing the subscript 10.
Oh.
Well, it's just a coincidence that they generated a 10 for me. When you do the problem, it might be a log base 7 or a log base 5. But if they show the subscript 10, you have to write that subscript 10, okay? You can't decide, well, that means common log, I'm not going to show it.
You're looking at this. Alex, are you looking at your number 11?
What's your base?
6.
A 6. You see that this 10 just appeared randomly. It's not intended to be as a common log problem. You're going to have to type in if if they show a subscript, you have to type it in. So even if they show the 10 subscript, you have to type it in, or I have to type it. So I write my log subscript 10. Do I need a fraction bar?
Mm-hmm.
Yes, because of the... Okay, so I have that fraction bar. What have I got on top? Z to the 9th, okay. And on bottom, Z plus 3. Since you have nothing else in that denominator, if you didn't enclose the Z plus 3 in parentheses, they wouldn't count it wrong. But if my argument has a plus or a minus, I'm going to enclose that thing in parentheses.
If they have it enclosed in parentheses, especially, I'm going to leave it.
Right. Mm-hmm.
So I type log base 10, right arrow.
What do you think he's going to type next? Y'all tell me, what do y'all think he'll type next? Or click? I think he's trying to tell y'all.
I'm going to click the fraction bar.
Yeah. If I just have a number over a number, I'll use a slash. But if I have anything other than just one term over one term, I do not use that slash on the keyboard. I use the fraction hot button. He's typed in the Z plus 3. Is there an exponent? No, there's not an exponent. I thought it was an exponent. Any questions there? Number 12.
Last year we did this one without
writing anything down.
Could y'all call out what I'm going to do? I'm going to type what first? Maybe you better write it down.
Maybe I better write it down. Okay. Hey, look, it says LOG, but it doesn't show the subscript. That's great. Then we don't have to show the subscript in our answer. We don't show the subscript. Alex, are you looking at this same problem, number 12? It's just an log, you mean?
Yeah.
Okay. And so you'll just type log, no subscript. Okay. I'm typing in my I'm writing my log. Do I need a fraction bar? Yes. What have I got on top? 5x plus 7. Do I have an exponent on that 5x plus 7? No. Do I have anything else on top? What about on bottom? Just the x.
If you
I
put
could
it in
enclose the
parentheses-
x in parentheses or not. It doesn't matter. It's when there's a plus or minus that I always make sure that I have it enclosed in parentheses. Fraction bar. And since there's no exponent on the 5x plus 7, if you didn't enclose it in parentheses, if you just wrote this, they'd count it right. I'm sure
I
of
see
it.
what you mean by this. They see what I'm typing.
Okay. If you wrote it without parentheses, since there's no exponent on the 5x plus 7, they should accept that just as well as that one.
Okay. Number 13. No.
Number 13. Ooh, wait a
1/4 ln y plus ln z.
1/4 ln y plus ln z. Okay. Well, once again, it says to condense. We're condensing logarithms. I'll write my ln notation. Do I need a fraction bar? Do I need a fraction bar? No, because there's no minus connecting the logarithms. If you're not going to divide, there's only one other thing we can do to the y and the z. What is it? You're not going to divide y divided by z. What do?
Plus is for
The multiplication. Y times z.
Oh wait, the 1/4.
Where does the
it go?
1/4 go?
Be in front of the logarithm.
The one, no, the
It's
1/4
already in
doesn't. It's already in front. So
We're
where's it
going
going to go?
backwards.
It's going to go up there as an exponent on the y. So we have ln y to the 1/4 times z.
Common mistake that students will do is put a plus in between the y and the z. No.
If your argument, look at these arguments, y and z, they didn't have any pluses or minuses there, so you can't have a plus or minus in the argument of your final answer. The only way you can have a logarithm with an argument as a plus or a minus is if you started with the plus or minus in the argument of the original problem. You had a z plus 3 in the original problem, you're stuck with that z plus 3 in the final answer. You have a 5x plus 7 in the original, you're stuck with that 5x plus 7 in your answer.
Now, I think students, for some reason, they hate fractions, but I think they get it right. This would be easier for most students if there'd been a minus here.
Yeah, you're right.
And there'd been a fraction bar. But you'll see why there's not a fraction bar, and why are we not putting any symbol in between here? Well, it's multiplication. So let me type that in. ln y raised to the 1/4. Get out of that fraction down there, and a z.
Do y'all see how he has it typed in? Okay.
Oh, wait, okay. Hey, do y'all think we can do this one without writing anything?
Type the log
I'm gonna
subscript
type
b.
log base b, then get out of that subscript. Y'all want to call out what I'm going to type in next? Will there be a minus or a division, a fraction bar? No.
So if we're not dividing, what's the only thing you can do to x and z? Multiply. So it's x. Does x have an exponent? If so, what is it? 9. Okay.
Nine.
X to the 9th. Get out of that exponent. What else do we have? Z to the 4th. I know. Wait a minute. Come back over here
To your writing?
to my writing. Well, no. I need to see what you have.
Oh.
Wait. Give me a moment. Let me see. Here's. If this were a multiple choice question, here's what they would have as one of the answers, one of the distractors, the wrong answer, and I'd be discouraged by how many people would select that.
But
They would have put that plus
put a
there.
big X there.
No.
Oh, by the way, I could have put my X and Z in parentheses.
But it's just not necessary. If the argument only has multiplication, there's no need to.
Parentheses. But it doesn't hurt if you do.
Doesn't hurt if you do.
Okay, so. Oh gosh, I'm sick of seeing that little note.
Okay, number 15. 8 ln x plus 9 is in parentheses minus 6 ln x.
We're going to go home and complain today. They were just writing that problem down and writing the answer.
I'll write my ln. Do I need a fraction bar? Yes, because of that minus right there says we need a fraction bar. What have we got on top? X plus 9. Anything else? To the 8th. Okay.
What about on the bottom?
X to the 6th. Good.
Do you ever impress yourself? Maybe around Christmas time, get this stuff out and look at it, and you're going to be like, what the heck was I doing? Oh, wow, and you'll impress yourself.
I knew how to do that. What were we doing?
Where are the steps?
Where's the steps? Where's the work?
Oh, gosh, all over. What goes down there?
X to the 6th. Number 16. Two ln x plus 3 ln y minus 6 ln z.
Condense.
We're condensing the logarithms. We're condensing. That's what we've been doing on this whole page. Okay.
And if it doesn't say condense, it'll say write as a single
Logarithm. Yes. ln. I write my ln. Do I need a fraction bar? Yes, because of the right there. So let's get started on top. What have I got up there? I couldn't hear you. X squared. What else? Y to the third. Good. Okay.
I'm so
And
glad
on the
you
bottom,
didn't say plus
you'd
y
be
to the third.
surprised how many. If this were multiple choice, they would have an x squared plus y cube as an option, and people would choose it. What have we got on bottom? Z to the 6th. I know when I'm saying it, it's crystal clear to me what I mean by this. But I think a lot of people may not understand what I'm saying, but I'm going to say it anyway. The only way you can have a plus or minus in the argument of your answer is if you have a plus or minus in the argument of the original problem. These arguments didn't have any pluses or plus or minuses, so you can't have an x squared plus y cubed here. Notice this argument, this answer had a plus in it. Well, the original problem started off with that plus.
Notice how it wasn't separated. Okay, so let me type that in.
Oh, God.
ln fraction bar. X squared. Get out of that. Y to the third. Go to the bottom and type a Z to the sixth. Any questions there?
Dig out your calculators, and if you don't have it with you, bring a calculator the next time. No, on Monday. Remember, in-class testing is on Wednesday, but 1 week from today, you'll definitely need a calculator for what we're doing.
Well, if we haven't insulted your intelligence yet this semester, I'm about to. Use a calculator to find the common log. That's log base 10. And to do this, the only thing you got to watch out for if you have a calculator like mine, when I hit log, it opens parentheses. Make sure you close them. Okay?
10 to what power gives you a 12? Well, 10 to the first power is 10. 10 squared is 100. So it's got to be something real close to 1, doesn't it? There it is. How do they want us to round it? Round to 4 decimal places. 1 point. Where's my calculator? Oh, is that a 07079? Is that going to stay a 1 or go up to a 2?
Hey,
Where's your calculator?
I don't know what's happening. It's not staying up on top like it's supposed
There
to.
it is.
Mm-hmm. State word. Simulation options.
That's okay, don't worry.
Okay,
Let's just finish this.
Yeah.
Show them the calculator. We want 4 decimal places. Oh, there it is. Okay, here, I'm going to do it. Okay. 1, 2, 3, 4. Is it going to stay a 9-1 or is it going to go up to 9-2? Use the usual rule of rounding.
This is the first time this semester we've had to type in
rounded
decimals.
decimals, so you better not. But how do you round? 4 decimal places, you look at the next one. If it's a 5 or bigger, what do? Do you move it up? If it's a 0 through 4, you would just drop those digits. That is an 8, so that 9-1, the 1 is going to be boosted up to a 2. 1.0792. The usual rules of rounding. 1.0792. Ooh, okay. Now, most calculators only have log and ln keys, log base 10 and log base e. Suppose you needed something else other than a log base 10 or a log base e. Look at number 18.
It's just spinning, Tim.
Well, it's not moving. Maybe that's why it's not going to load. Because you're moving that mouse so fast.
I wonder if I said save and go back in. Just bear with us. We're almost done. Oh, there.
I did it. Okay. Look at that. Log base 9 of 60. Most calculators don't have a log base 9 key, so how are you going to punch that in?
I have a log base 10 and a log base E.
That LN and LOG. That's what most calculators have.
It's been a while since you've had a formula. He's about to give you something called the change of base formula.
Change of base.
And it's how you...
The change of base formula.
Like
Suppose you needed to evaluate a logarithm, and it was a
base 9.
Base 9 or whatever. Something other than log base 10 or log base E. You can take log base B of A for anything or argument. You can convert it to any base you want to. But if you're using your calculator, you only have 2 choices. Either the common log of A divided by the common log of B, or we haven't done that much stuff with ln, but that's my preferred logarithm. the natural log of A divided by the natural log of B.
Don't mix them.
You can't mix them. You can't decide to use an log on top and an ln on bottom. You either use log on top and log on bottom, or ln on top and ln on bottom. So this is number 18. We have log base 9 of 60. Log base 9 of 60. The instructions say use the change of base formula. Now there are some calculators that have this wonderful little log base with a little it's a log and it has a little box down there. And
then it has a box here.
And it has a box here. And so you have to type in the subscript and then you type in the argument. Well, that does the change of base formula for you, but my calculator doesn't have that wonderful little key. So I'm going to I prefer ln. You can use log, it doesn't matter. ln. The argument, the big thing, the thing that's written big, that's what's on top. The thing that's written small is what's on bottom.
The subscript.
The subscript is the thing that's on bottom.
Now, to punch this into your calculator, be careful. If your calculator is like mine and it opens parentheses, you've got to close them or it's going to be wrong. I'll go ln.
Look at open to parentheses. He's going to type that 60 and then he has to close it.
If I don't, it's going to give me the wrong answer.
Divided by, he types that ln. Notice it opened a parentheses. Basically, here's what you're typing in. Mm-hmm. The 60's in parentheses, the 9's in parentheses.
Oh, I didn't.
How do they want it rounded? 4 decimal. 4 decimal. So what would that be? 1.863. What do y'all think he's going to do?
34 or 35? 34. Did y'all hear that?
What came after the 4?
A 1.
So you're not going to boost that 34 up to 35. It stays a 1.8634.
1.8634. Sounded like you were sighing.
I was just exhaling. I've been talking almost non-stop for 2 hours.
Mm-hmm.
Oh. And writing with my arthritic finger. I think it's another change of base formula problem. Okay.
Oh gosh.
It's just trying. I was bragging about the internet, the Del Mar internet earlier. And now they're doing this, you see?
Punishing.
I'm punishing me for, just because I said it was working so good, it's karma. Oh, it did it? Okay. Log base, the same instructions, use the change of base formula to find log base. Is that a 9?
It's got to be a 9. It can't be a G.
I thought it was a G. 0.06. Oh, by the way, so, Alex, you have your calculator. Did you punch it in with LN or LOG?
I was following you.
So you used LN? Anyone, Tony, show if they know. Look up here. If you used LOG, you should still get the same final answer, but you have to close those parentheses. Sure enough, 1.8634.
And I
that was for number 18.
I don't want y'all to think I'm lying when I say you got to close the parentheses. I typed in ln 60 divided by ln 9 and never closed the parentheses. Are we going to get the same answer? No. Not close. Okay? So
clean off that computer screen. That calculator screen. Okay, I'm going to use ln. What's going to go here on top? It's either 9 or 0.06. 0.06.
I always think the subscript is like subterranean on the bar.
Yeah.
Now punch in those parentheses that I need to enclose.
Oh, yeah.
0.
Our calculator.
0.06.
Alex, does your calculator open a parenthesis?
It open.
It does, and so you have to close it.
them. Some of them don't.
Okay. If you have trouble punching the stuff into your calculator, the next time, round to 4 decimal places again, get here a little early so we can...
By the next time, you mean 1 week.
Well, yeah, 1 week from today. So it's a 280. Is it going to be a 04 or a 05? 05. 2
No,
8.
04.
I mean 04s. I was thinking 04. I nodded and said correct, right? But my mouth said 5. I tell you.
Mm-hmm. Oh, wow.
Any questions there? Okay. Anyone with their calculator that has a calculator, they having trouble? You having trouble punching it in? No. Okay. What about in the peanut gallery? Time you to open the wall much so I can barely see you getting the stuff punched in. Yes. Okay. I want to go back to that statement regarding inverses that I made at the beginning of class. My goodness. No wonder my arthritic fingers are so achy. Look at all this. Here it is.
There.
Okay. Y'all recall these statements here. I want to rewrite these two statements in terms of E and ln. Remember I said that exponential and logarithmic with the same base are inverses, so when they're performed consecutively, they cancel each other out. So I want to rewrite that statement using the natural logarithm. The natural logarithm is denoted ln. Ln, what's that assumed base of the natural logarithm? We don't show a subscript. What do we assume it is? E to the x. Ln e to the x reduces just to x.
So ln
Because
and e are
ln and e are side by side. They're inverses. When performed consecutively, they cancel themselves out. Or it could be the other way around. The exponential base could be first. E to the ln x reduces to x. I'm just restating, instead of in terms of b and log base b, e to the ln e to the x. I'm just restating those. So I'll say note, e and ln are inverses. When they're performed consecutively, they cancel each other out.
You know what? You should have done like last year. Flipped to another page.
I should have.
Now we're going to do the last problem.
In this assignment, number 20.
Oh shoot, I didn't type in this answer. What was it?
Negative 1.2804.
Negative 1.2804. Oh. Okay, good.
Oh.
I'm just trying to tell them. What I'm trying to tell you is don't type an I in. It's ln. So here we have f of x
is equal to ln x, and they want us to find, there are three parts here, A, B, C. They want us to find f of
e to the negative 6.
E to the negative 6. F of
e to the ln 5. So we're going to be plugging in some stuff here.
And f of
e to the 6 ln 5. He's writing down all three parts.
Okay, switch it over so they'll see what I was doing. I wasn't just killing time up here.
Like small enough so that you can get it all in that line.
I'm going to have to.
Get all this paper here. You could have spread it out more.
No. You need to remember function notation. How does function notation work? That says go to your function f, this part A. It says go to your function f, and wherever you see an x, replace it with e to the negative 6. So we have ln e to the negative 6. What's that going to reduce to?
E and ln are side by side.
The inverse functions perform consecutively. Let's see, which one am I using?
ln.
This one here? What's going to happen? They cancel out, leaving you just negative 6.
I'll type in the answers in a moment.
Yeah, type them in all at the end. Part B, that says go to your function f and replace any x you see with e to the ln 5. So, replace that x with the green e to the ln 5. Some people get into their head that it's just a cancellation free-for-all whenever a problem has e and ln and come up with the answer of 5 for this. That's not correct. There's a one-to-one correspondence. You can cancel one e with one ln.
You can't cancel two ln's with one e.
Nuh-uh. So you could either say, okay, I'm going to cancel right here the e and ln, and what does that leave you with? That ln 5. Or there's another place you could cancel. What about this? E to the ln 5. That green stuff. Remember, e to the ln, they cancel as well. So you could cancel right there and cancel the e to the ln. But you still have what is your final answer? ln 5. So it doesn't matter where you cancel. The point of this problem is you're not just going to have a 5. It's not just a cancellation free-for-all every time you see e's and ln's together. You can cancel one pair, and then you're still left with one ln, so an ln 5. And the last one.
Function notation, you go to the function, replace the x with what's in the parentheses.
So we have ln, replace the x with this big messy green e to the 6 ln 5. This isn't like the previous problem. ln e is performed consecutively, but what about here? Or is this green e and that green ln, are they consecutive?
Or is there something in between them?
I don't think those are performed consecutively. The only place, because there's that 6 between them, the only thing you can cancel right there, and you're left with 6 ln 5 for your final answer.
Oh, wow. Oh, I better type these in. I know it's a lot, what we've done.
Today, yeah, we've done a lot.
Once you get the hang of this, oh, wow.
Okay.
What was this one? 6 ln 5?
6 ln 5.
No capital I's, please. Just ln's. Okay? Lowercase letters, no capital letters. Oh gosh, I'll reluctantly ask, are there any questions after all of this? Oh gosh, I'm laughing because it would be natural to have a lot of questions. if you weren't too exhausted. Okay?
Some of y'all seem to have gotten the hang of it.
Yeah.
That vocal minority seems to have gotten the hang of it. So
Any questions before I stop recording?
2 hours and 4 minutes. Huh.